Now you can start this question.
Okay, today we're going to solve an interesting question called kth largest sum in the binary tree. So we're given the tree itself and a positive integer k, which means it's bigger than 0. The level sum is a sum of values in the nodes that are on the same level. So if you solve the question binary tree level order traversal, this is a very similar question, except we just care about the sum of the nodes values in each level. So at the end, we're going to return the kth largest level sum in the tree that's not necessarily distinct. There are fewer than k levels in the tree, return -1. Okay, so what we're going to want to do is use a deck here to basically understand when we've got to the bottom of the tree. So we're going to keep each level, we're going to keep the nodes of each level in the deck at once. And we're going to keep track of a list called level sum. And we're going to iterate through each level of the deck. So the first iteration is only 5, so this is only I equals to 0. And then we're going to pop left from the deck to get the actual node. We're going to make sure that the node is not none. So if cur is not none, then we can append the value of the node, which is 5. And cool, to move down the level, we have to append the children. So we're going to append the left child of 5, which is 8. And we're going to append the right child of 5, which is 9. So after we finished one level, we're going to go back here and clear the level sum list. But before then, we're going to create a new array called TMP to keep track of the sum of that current level. So we're going to append, if there are actual elements in level sum, then append the sum of that list. All right, so in the first iteration, this is going to be 5. In the second iteration, this is going to be 17. The third iteration is going to be 13. And the fourth iteration is going to be 10. Make sense?
Yeah.
Okay. Cool, so now we have all of the sum of each level in an array. So now we want the kth largest sum in the tree. So the best way to do this is to use a heap. And because the min heap keeps the smallest value at the top, and we can do some tricks with negation to ensure that we get the kth largest. So we're going to declare a min heap, which is basically an array in Python, and we're going to iterate through our TMP list. And just to print it so you can see right here. So, okay, let me finish this first. But if you can see right now, TMP is going to be equal to 5, 17, 13, 10. 5, 17, 13, 10. Makes sense, right? So now we're going to iterate through TMP, and we're going to push into our min heap -t, because the negative number, the smaller negative, the bigger its positive variant is. And after we pushed all these to the heap, now our heap will basically look like -17, -13, -10, -5. Right? So, because again, the smallest is at the top. And don't worry about this ordering, because the heap actually rearranges itself. The heap kind of looks like a tree. So after we pop -17, -13 is going to be at the root of the heap. So now we can pop k times. So we're going to run a loop. While k is bigger than 0, we're going to set a result equal to the popped value, equal to -1 times heap q dot heap pop min heap, because we want to renegate it. So the kth largest is 13, not -13, right? Because we already did the negative, so we have to renegate it after we pop it off. And then we subtract k by 1. And then when k becomes 0, we'll get out of this loop and we can just return our result.
Okay,
so that should
nice.
Let's see, heap pop min heap. Negative y times this. Why is this not working? Oh, why? Because we have an edge case here. If there are fewer than k levels in the tree, return -1. We can't just keep popping when there's not even k in the list. So if length of k, well, if length of TMP is less than k, if there are fewer than k levels in the tree, because the length of the levels are the length of our TMP array, then we can just return -1. There you go.
Mm-hmm.
All right.
Mm-hmm.
Are you recording? Yeah. Hello.
Yeah.